Hello, this is Yuri Bosikov, and this is my first article, Tools for Assessing the Impacts of Climate Variability and Change on Wildfire Regimes in Forests. This article was written by Hetty Herawati, Jose Ramon Gonzalez Alabaria, and others. Was published in 30th April of 2015. Abstract. Fire is an intrinsic element of many forest ecosystems. It shapes their ecological processes, determines species composition, and influences landscape structure. However, wildfires may have undesirable effects on biodiversity and vegetation coverage, produce carbon emissions to the atmosphere, release smoke affecting human health, and cause loss of lives and property. There have been increasing concerns about the potential impacts of climate variability and change on forest fires. Climate change can alter factors that influence the occurrence of fire ignitions, fuel availability, and fuel flammability. This review paper aims to identify tools and methods used for gathering information about the impacts of climate variability and change on forest fires, forest fuels, and the probability of fires. Tools to assess the impacts of climate variability and change on forest fires include remote sensing, dynamic global vegetation and landscape models, integrated fire vegetation models, fire danger rating systems, empirical models, fire behavior models. This review outlines each tool in terms of its characteristics, spatial and temporal resolution limitations, and applicability of the results. To enhance and improve tool performance, each must be continuously tested in all types of forest ecosystems. First, introduction. Fire is an important driver of ecological processes in many forests and determines their species composition and landscape structure. Wildfire are natural processes in many forest ecosystems, but they can have undesired side effects such as degradation of vegetation, impacts on biodiversity, loss of leaves and property, and off-site effects such as smoke, impacts on human health, and carbon emissions to the global atmosphere. These undesired impacts may intensify because fire activity is projected to increase for many regions of the world under the current change in climate. Then second, remote sensing approaches, monitoring and mapping fires and fuel characteristics. Remote sensing data and methods can model the possible impacts of climate variability changes in forest fire regimes and provide the required information on early warning system. Dynamic global vegetation and landscape models. Dynamic global vegetation and landscape models can assess the effect of climate variability and change on fire regimes through vegetation evolution assessment. They simulate vegetation, fuel fire hazard, dynamics at different spatial scales. These models calculate long-term and large-scale predictions of vegetation evolution under changing conditions. Fourth is modeling fuel characteristics and fire integrated fire vegetation models. Integrated fire vegetation models can also be used to study how fire activity may change in the future. DGFMs and IFVMs differ in terms of their focus. IFVMs integrate fire and vegetation models and study the combined effects of changing conditions on vegetation dynamics and fire regimes and their interactions. Fifth is modeling dynamics of fuel flammability, fire danger rating systems. Fire danger rating systems have been used to project fire danger in the future, but they often work on coarse resolution scales and their output metrics are usually dependent on climate conditions. Six, modeling fire ignition and occurrence empirical models. Seventh, modeling fuel flammability, fire occurrence, spread, and effects. Fire models. Fire models are useful to predict fuel flammability, fire occurrence, fire behavior, and fire effects under certain climate weather conditions. And the last eight is conclusions. A number of tools are available to assess the impacts of climate variability and change on forest fire. The chosen tool should fit the objectives of the research, policy, and management decisions. These tools have specific purposes, characteristics, and limitations. Remote sensing DG, VMs, and FDRS are useful to analyze fire hazard, while empirical models are used to predict fire risk and frequency. The suitability of the tools for particular ecosystems is also important. Fire models may not be suitable for tropic humid forests as they are mainly developed for temperate or Mediterranean forests. Remote sensing and all fire models can only provide short to medium-term assessments of historical fire occurrence. While DGFM assessments can be used over longer time periods, remote sensing and fire models can provide detailed fire assessments suitable for subnational scales, while DGFMs have relatively lower spatial resolution suitable for continent or global assessment.